Hello everybody and welcome to our second lesson in our unit Absolute Value and Piecewise Functions. Last time we talked about absolute value functions. Today we will analyze piecewise functions. Our objectives will be to analyze piecewise functions, to identify domain and range, zeros, intercepts, increasing, decreasing intervals, and end behavior, all that good stuff, right? And we will, given a real-world scenario represented by a piecewise function, identify the domain and range. So what is a piecewise function? A piecewise function is a function composed of several subfunctions over a specified interval of the domain. Let's look at this function here, and from the last lesson you remember this is an absolute value function. It has the vertex here at positive 4 and 1, and the slope or dilation is 2 up and 1 to the right. So as an absolute value function, this is written by f of x is equal to 2 times the absolute value of x minus 4 plus 1. Remember, the move to the right is indicated by a negative, and the move to the left indicated by a positive. But we could also look at this function in a different way. We can look at this function as two separate linear functions, two separate lines that point in different directions, and analyze the function accordingly. And what comes in very helpful to do that is the point slope form of an equation. Hopefully you will remember that from Algebra 1 or geometry. Y minus y1 is equal to m times x minus x1. So let's look at one part of the function, this line, and we know that this line goes or has the point 4, 1 as part of it. And if we look at the slope, up 2, 1 to the right, our slope m is equal to 2. We can use this and plug it into our point slope form. Y minus 1 is equal to 2 times, open parentheses, x minus 4. Do our distribution. Y minus 1 is equal to 2x minus 4. Add 1 on both sides. Y is equal to 2x and see 2x minus 8. Y is equal to 2x minus 7 is our equation. And if we look at where that function is actually valid, what is the domain of this function? The domain of the function is x is greater than or equal to positive 4. Let's look at the other part of the function. It also has the point 4, 1. The slope in this case is down 2 and 1 to the right. In other words, m is equal to negative 2. Plug in the numbers into our point slope form. Y minus 1 is equal to negative 2 x minus 4. Distribute the negative 2. Y minus 1 is negative 2x plus 8. Add 1 to both sides. Y is equal to negative 2 plus 9. Our domain Our domain goes from negative infinity all the way up to 4. In other words, x is less than 4. We can now combine these two parts as a piecewise function in the way we write it, f of x, and then we use a big braces and write down both subfunctions with their domains. In other words, negative 2x negative 2x plus 9 if x is less than 4, and 2x minus 7 if x is greater than or equal to 4. And there is your first piecewise function. Let's look at another example. Look at this function. It looks quite complicated, but don't worry about it. We're going to go step by step, and it's going to be just fine. Okay? Starting from the left, this is the part of the function we're looking at. And we can see that the slope is 1/2. And it goes up all the way to the point negative 3, 0. Plug that into your point slope form. Y minus 0 is equal to 1/2 x minus negative 3, in other words, x plus 3. Y is equal to 1/2 x plus 3/2. What's the domain of this function? This function goes from negative infinity all the way up to negative 3, but negative 3 is not part of it. So the domain is x is less than negative 3. Let's look at our next part. This is a horizontal piece of a line. Horizontal pieces of lines are really constants, and essentially the function is y is equal to 1. And what is the domain of this part of the function? It starts at negative 3, and negative 3, as indicated by the closed circle, is actually part of it. So negative 3 is less than or equal to x. And then it goes up all the way to negative 1, which is not a part, indicated by an open circle, less than negative 1. Let's look at our last part, which is an absolute value function as we have seen them now for some time. It has a vertex at 1, negative 3. And it has a dilation of 2. I hope you caught that. The dilation is obviously not 2, it is 3. And our function therefore is y is equal to 3 times the absolute value of x minus 1. Remember, change the sign. Minus 3. And the domain of this part of the function, it starts from negative 1 being part of the domain, and then it keeps going to positive infinity. In other words, x is greater than or equal to negative 1. Let's now put all this together as a piecewise function. F of x is equal to, now use your big braces. The first piece is y is equal to 1/2 x plus 3/2 if x is less than -3, y is equal to 1 if -3 is less than or equal to x is less than -1, and y is equal to 3 times the absolute value of x minus 1, the whole minus 3, if x is greater than or equal to -1. Now I'm going to make some room on this page so we can talk about the characteristics of this function. You can of course stop this and copy anything that you haven't got on your note page yet. And for the characteristics, I suggest you use the left margin. So let's go. Okay, here we go. The domain goes from -infinity to +infinity. Notice that wherever we have open circles, which might make us nervous and think that we have a gap, there is a closed circle right above it, closing the gap, so there are no gaps in the domain. And for the range, the same is true. It goes from -infinity, as indicated by the red arrow, to +infinity, as indicated by the orange. And again, that part that has open circles is fully covered by the orange curve. The end behavior. As x goes to -infinity, f of x also goes to -infinity. And as x goes to +infinity, now on the right, f of x goes to +infinity. Increasing intervals, we have increasing intervals from -infinity all the way up to -3, or in other words, the red part of our curve. And remember to use your unity symbol. We have another increasing interval, which is the right part of our absolute value function bit, which goes from +1 to +infinity. There's only one decreasing interval. That decreasing interval goes from -1 to +1. Let's look for x-intercepts or zeros. Remember, x-intercepts zeros are the same thing as are solutions and roots. All four words mean the same thing. Always remember that. We have two x-intercepts. One is at 0, 0, in other words, the origin. The other one is at 2, 0. Remember that -3 and 0 is not an x-intercept due to the open circle. And we have one y-intercept, which is at the origin. Remember, whenever a graph goes through the origin, that's both an x-intercept and a y-intercept. Very good. Now go ahead and watch the second video that concludes today's lesson.